Hello again, and welcome back to Advent of Code 2025 in MIPS assembly for the PlayStation 2. Today we're up to day 4, so let's have a look here. It is called Printing Department, and lovely, we have a grid. Grid problems are one of my favorites actually since starting to do assembly. They're just so fun to actually go through and solve. So what I've got here is that I've got some forklifts and rolls of paper that are arranged in a large grid. The forklifts can access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. So you have a position, let's say this position here, the 8 ones are these 1, 2, 3 up here, these 1, 2, 3 down here, and 2 over there. Those are the 8 adjacent positions, north, south, east, west, and then the northwest, northeast, southwest, southeast sort of cardinal directions. Right? So if we figure out how many we can access, we can spend less time looking for a way to break down the wall into the cafeterias, right? So the first part, we're just counting how many we can access using that criteria. And of course, with the second part, we remove them. We remove all the ones we can access, and that will allow us to access more rolls of paper. And then remove those, and we keep removing them until we can no longer access any rolls of paper. And we want to know how many we remove total in that process. So we don't have to work out how many we've got left. We can just sum up all the ones we remove to get that final result. Alright, and today will be another fairly easy one, so let's get into the code, shall we? So, start off here, the first thing I'm going to do is I need to find out the width of my grid. The fun thing about doing these grids in just straight in memory is that we have a character, let's see, this 0, the 0A, hex 0A is the new line character. So to work out the width of the grid, we can just read from the beginning of the input until we hit an OA. And when we've got that width, and I believe we add 1 to it, regardless of every time we loop through. Once we get that width, in order to navigate up or down through the grid, we just add the width of the grid to our current memory address within the grid, right? And that way we can go, like if we're at this address here, this position here in the memory, and we add the width of the grid, we'll go to this position here, right? And we subtract it, we go here. And then for our bounds checking, if we check if we're less than the memory address of the first position in the grid, then we're outside of the grid. If the next position on our left from say this position here, or the next, well no, sorry, if we're the next position to the right is OA, then we're on the edge of the grid there. If the position to our left, so subtracting 1, is OA, then we're on the edge of the grid to our left there. And if we go beyond the memory address that's the last address in the last position in the input, then we've gone beyond the bounds of the grid as well. So it's really easy to navigate a grid just in memory, and to check if you're within the grid or you've gone out of bounds in some way. So yeah, grid problems can be really easy and really fun to do in just straight up assembly. Right, so we've got this little loop here. The width is going to end up, looks like I am counting it up in S0. No wait, what is it? Add 1 to S7. Yada yada, that goes through there. I do a subtraction here. Okay, that's alright. So I start off with S7 as my input, is the start of the input. S1 is OA, so I'm looking for OA to exit. I load the byte from S7 into S0, I check if it's OA, and I always add 1 to it, to S7, and if it isn't OA then it loops back through here. And then once we get to the end, I load S6 into input text. I subtract the address that I ended up on in S7 from, I subtract S6 from the address that I end up in S7. I put that into S5. Right, so that will end up with the width of the grid, and this is only a 32-bit subtract. It's a sub, not a D-sub, so it's safe because the PlayStation 2 only has like 32 megabytes of memory, and we don't use 64 bits for addressing, so that's safe. And then I load the end of the grid into S7, and then I want to make a copy of the grid, because especially part 2 will be destructive, and I want to be able to reset this program so I can run it over and over. So I want to make a copy of this out of memory first. So I get that address of the start of the, I load S1 as grid copy. That's where I'm going to be copying the grid to, and I've got this check to see if I'm still less than the end of the input. Once I've gone beyond the end of the input, I go to run solvers. Right, you start the solution. Then I load 8 bytes, a load double, which is 64 bits. Load 8 bytes out of the input, and I store it in the grid copy, and then we add 8 to each of those pointers and jump back to here, using the branch delay slot here to add the 8 on the S6 one there, just because. And then once we've got our copy, I load that S6 the input text again, subtract the length. Okay, yep, I see. I subtract the length of that. I probably could have taken it from here, or I would have just had to subtract 7 from the S1 to have gotten the end of. No, I probably could have just used this. I probably could have just used S1 here actually. Loaded that there and used S1, moved S1 into S7 to have the end of grid copy. So instead of this part here, the subtraction here, I could have probably moved S1 into S7 here. Anyway, that's fine. No problems. Because S1 here would have been the end of the input, the copy of the grid. Would have been the end of the copy of the grid. And then I move S6 into S4 for some reason. I think it'll be for my bounds checking, because I'm going to be moving S6. That'll be my position in the grid, and S4 is going to be the start of the grid, to check my bounds checking. Yep. Then I branch into this solve silver and solve gold, and so let's move down, shall we? I've got a big bounds check thing here. We'll check this when the first time I come across it, and there's another check access thing here as well. We'll check that as well when we get to it. So the silver, here we are, solve silver. We move the stack pointer and put some registers into the stack. I think we're fine there. Yep. I load S1 with 40, OX40. I'm not sure why I'm doing that yet. We'll see how that goes. I'm not sure why. We'll see why I do that in a minute, I guess. We've got this here to check when I've ended the grid, and once I have ended the grid, we'll go to oh no, I'm using S4 to move I'm using S4 to move through the grid, and S6 is the beginning of the grid. Either way, it could be either or. Either way. Anyway, so that there is checking that I've reached the end of the grid to exit out of this loop. So we load byte. Okay, so S4, this thing here, 40 must be the at character. Hex 40 is the at character in ASCII. So that's what that 40 is for. Right, so we load the byte out of the grid. We check if it's not equal to hex 40, it's not an at symbol, then we go to the next in the loop. We branch down here. We add 1 to S4, and then we go into go back up silver loop. Right. Yep. And so, like, I'm not actually even moving north south, like, down through the grid. I'm always going to the left, or to the right. Actually, I'm always going to the right. Like, because I'm just checking. You're not actually like this isn't a path. Like, you're not traveling a direction really. You're just checking like everything in the grid. You're checking all of these. So I just go along like this, and so it will check. It will land on the OA, the carriage return, but because it's not an ASCII at symbol, it doesn't matter. Like it won't actually check it for anything. So I don't have to have a check for that at this point. So that's fine. So if it's not an at symbol, we just go to the next part of the loop, right? Then you do a check access. If it is an at symbol, we branch to this check access. And if S0 comes back, because S0 is going to come back, if it's equal to 0, if S0 is 0, then we go to the silver loop next. Right? So that means that it's inaccessible, essentially, right? But if it is accessible, then we load this the result for silver result, and we add 1. We load the value that's in silver result, we add 1 to it, and we store it back. So let's go, and then the last part in here is, of course, loading all those things out of the stack, restoring the stack again, and going back. Yeah. So let's have a look at check access first. So check access, this subroutine here, again, backing up stuff in the stack, and I've got a bunch of copy paste in here, as you can see. I move S3, I put a 0 into S3. I'm not sure exactly why I choose S3 here, that's fine. Okay, there we go, that's why I do it there. Alright, I could use S0, but whatever, doesn't matter. I do have an S0 is sort of hanging around over here. What is S0 at this point? Because I'm using it. It might be in the, it's probably in the balance check here. Yes, it'll be used in the balance check. Okay, that's right. Okay, so move S3 0, right? We add 1 to my position in the array, so I'm going to go looking, like say I'm at this one here. I'm going to go look at this one here first. We add 1 to it, it's to the right, and then we branch to the balance check, or we jump to the balance check, jump and link. When we come back, I guess I could have moved that add down underneath this actually, but it's fine. I could have moved all the adds underneath it. It's fine. It's fine. It's fine. Doesn't matter. You go to the balance check, and then I add what comes back in S0 to S3. And then we move into the next one, which will be right down. Right, so the next one will be the one down here. And so I check that one there by adding the width of the grid to the current position that I'm checking on, which is S4. Right, and then do the same balance check, the same thing over again. then we do down, which will be subtract 1. And you notice I use, I think I've done it, sort of shown it before, but there is no subtract immediate in the MIPS assembly, so you use add immediate and you use a negative value to do the subtract 1, which is just, you know, reducing the number of instructions in the instruction set there. That's fine. Right, so the next one is this one over here. We subtract 1 from our position in memory there to end up here. We balance check that one. Then we subtract another one for the next, down to the left. Right, this one here. So we subtract 1 more to get there. Then we have to use a sub because we want to go up to the left position, which is over here. We do another balance check there. And then we subtract 1 more to do the up to the left up. Where are we? Over here. Right, to do that one there, and then we add 1 to do the upper one there, and then we add 1 more to do the upper right one up here. Right, so that balance check is going to be looking for roles, well, all sorts of things actually. So that's the balance check, right? So once we're finishing this balance check, I'm going to do this here, set less than immediate, right? So if S3 is less than 4, right? Because we need to, if there's fewer than 4, is the thing that we're checking for. If it's less than 4, this S0 will be set to 1, right? So when we come back out of this here, if this is 1, we will not branch, right? So if it's less than 4, it will be set to 1, and we will not branch there, and it will add 1 to the silver result. So let's have a look at our balance check. I put S1 into the stack. That's the only thing I put into the stack. I'm not going to branch anywhere from here, so I don't have to put the return address in the stack. That's alright. We do a set less than here to see if we have we've gone beyond the start of the grid, if we've gone, you know, if we're outside the beginning of the grid. If it's not equal to 0, then we go to balance check end, right? And so this value that ends up in S0 here, this value that ends up in S0 here is going to return out of this subroutine, right? So if it's 1, oh no, because I did an add I -1 here. Okay, so if I think I made a bit of a mistake here when I end up sort of reverse expecting that I could get out the exact value of S0, but because the set less than, right, you can't just switch around the two results because it's set less than, and if you switch them around it's set greater than or equal to, and sometimes that's not exactly, that doesn't get the same as you're expecting, and so I think that was a problem. I can't think of it why right now. It should actually work if I switch that around, I think. I might have to change this here, but I think it would work. Anyway, so it'll set that to a 1 if this here is less than this one here, right? If it's not equal to 0, so you are beyond the start, then I want to return a 0 to say, hey, this one's not a roll of paper, so I end up subtracting 1 from it here. It subtracts 1 from it regardless, but I'm going to set, this is one of the cool things, one of the sort of cool things about doing these set less thans is that because if I don't follow this branch, I'm just going to change what's in S0 anyway by doing this check here. So it doesn't matter that this is in the branch delay slot. It's, yeah, kind of useful that you can do that. Anyway, so the next one is checking the other end, I think. Yeah. Now I'm checking if we've gone beyond the end of the grid over here, right? So if check the wrap end, I set this one to 1 if this is less than here. In this case, if it's true, then I'm still within the grid. Wait. But that shouldn't be a branch and escape outer yet. Wait a second. That seemed... what? Because that would be branching out if I'm... Huh? Huh? What? Excuse me? That doesn't seem right. But what? That would always... wouldn't that always branch out? Huh? Set less than if S4 is less than S1. S1 is the end of the grid though, isn't it? No, wait. Did I set S... no, S7 is the end of the grid. What's S1 right now? Because that should be S7 and that should be S7 and S4, I think. What is going on here? Wait a goddamn second. So you can tell this is unscripted because at some point I look at my code and go, what the hell am I doing? What? I'm going to be loading bytes into S1 over here in a second. What is S1? Am I S1 is 40. S1 should be 40. Hex 40 here. The hell? I'm pretty sure what I should have in here is like this, like that, right? So if that is less than my current position, then I've gone beyond the bounds. I'm gonna save this, and I might rebuild it up once I'm done and see if it breaks everything. Anyway, okay, I think that's the actual fix of the wrap end there. Regardless, right? So now it should be checking if I've gone beyond the end of it. Let me just check up here a second again. The run solvers. Yeah, that should be the end of the input, right? Because I've got the input down here. Yep. Okay. Anyway, so the next one I want to check if I'm on that carriage return line, which would be the I'm on the edge of the grid over here sort of thing, or over here, right? If I've gone off the side of the grid, you could say. So I load this time for some reason I'm loading S0 with OA. Now load the byte into S1. Let's check wrap side. Oh yeah, check wrap side, of course. If OA, we branch, bounds check. If S0 is less than, if it's equal to, right, I see. Yep. So if the character in this position is equal to OA, then we branch to our balance check, and I move 0 into S0 so that we end up so that ends up saying that there's no block in that position, and then I load S0 with O40, which is the checker roll of paper. If it's equal to, if the character that's in the this position I'm checking is a roll of paper, we branch to balance check end. I load S1 into S0, and then I also, and that's in the branch delay slot, so it's always going to load that regardless of whether we branch or not. But if we don't branch, I'm going to subtract 1 from that, and then we exit out of the balance check. So the only way that you end up with a 1 in the S0 is if you take this branch here, in which case it will have a 1 in S0 and it will skip this subtract 1 here. So of course when you come back from the balance check, we add whatever is in that S0 to S3. And so if S3 is 4 or more, then we can't remove that roll of paper. Okay, so that's how the balance checking works. That's how the the balance checking for access to a roll of paper works. All right, and so that's all the silver part. Let's look at the gold part. Now the gold part is basically the same, except we want to loop it, right? So I've got a setup gold here at the start. I've got this gold res here in T7. We set up gold, so we load T7 from T6, right, which is the gold res here. Don't know why exactly, but hey. And we've got this S4. I've got the 40 here in S1. Right, we've got the same grid here, right, doing the same thing here, but the difference here is that when we get an accessible roll of paper, we clear out that character in memory. We store this 2E into it, which I think is a period. I think it's just a period like this, right? So we are modifying the grid this time, right? And we go through same business, except there should be a way to actually completely get out of this, which must be that's right, here, this thing here. So what I'm doing is that I'm saving in this setup part here, I'm saving the value of gold rest before we start a loop of removing rolls of paper into T7. And if that does not change after a round through this gold loop, then we could not remove any rolls of paper and we are finished with the solution. So yeah, everything else is the same, except that we are we're modifying the grid to put periods into removed rolls of paper, and then when we fall out of the loop, we exit the grid, we check to see if the value that's in gold res presently is the same as it was before we went into the loop. And we load the value out of the stack for S4 regardless. If it's not equal, then we go back to our setup gold and we do this again. We go through the loop again. But if it is, we're done and we'll end up going back out. And that's it. That's all the code. Alright, so let's bring it up. Let's bring this up here. There we are. Alright, let's run it. That one there. Let's check the result. 1, 3. Let's see. Wait. Let's see if we can see it on here. Yep. 1, 3, 5, 6 for the first part. And where are we? 8, 7, 1, 3 for the second part. Alright, so that is correct. Now, where is my compiler? Here we are. Luckily, just the other day, decided to try something, and so I'm kind of in the right place to run this again. Hopefully everything points to everything correctly, and it did compile, so let's shut that down. I know you can't see it. I kind of don't want to make any more things of it right now because I don't know what I'll show off. So where is my... Oh no, I was in the right place before. Where is my directory? Let's bring up the newly compiled version. Can I show that I have actually... Well, I guess if I use the debugger, let's bring up the debugger. I'll show that I've actually got the change in here. I'll bring that up. Let's see, where's a window? Window capture, capture 5, good enough. Debugger, yep, bring that up. There we are. So here's the debugger that I've got up. Where am I right now? It's hard to tell where I am right now. Where the controller reads there, so I should be up here somewhere. That looks like gold, I think. Yeah, because I've got the T's in it. That'll be the silver solution. This thing here, and so this one here will be the convert. Right, so I've got the store double S1, set less than S4 and S6, and then I've got this one here, set less than S7, S4. So that one there is updated. It is the updated version. You can tell it is because it's in the debugger. Now let's see if it works or if it breaks. Let's run it. It's the same solution. Hooray! So it worked anyway. Oh, and now you can see the grid in memory as well. It's quite a big grid actually. So this is a sneak peek into the debugger as well. You can see it takes up quite a bit of space in memory really. There it is. Yeah. They really need like a scroll bar, a proper scroll bar on this, because like getting through memory is a bit of a pain. You can just go to addresses. You're like, where exactly am I typing the address? Anyway. Alright, so yeah, that was day 4. A little bit of a hot fix there on the end because a weird, I mean it wasn't a bug because it worked, but then it was a bug because, you know, there may have been an edge case where it would have screwed something up, but you know, it's just things you find. Alright, so that's it for day 4. I hope to see you again on day 5. I'm actually planning to do another video, hopefully shortly, where I'll go over properly how I do the text output in on the PS2. So I hope to see you there as well, but more importantly, next week, day 5. See you then.